Okay, we have a genetic experiment with peas that result in one sample of offspring that consists of 433 green peas and 151 yellow peas. We want to construct a 90% confidence interval to estimate the percentage of yellow peas. So if you look at your formula sheet, and remember this is available for you for download, and I recommend you download it and start working with it so you have notes on it. As you get to your things, right here on the second page is the information you need for proportion. So you can see that this is our true proportion, and we're going to take our sample proportion. The reason we know proportion is our question here is percentage proportion, same thing. Our sample proportion, so in this case our sample proportion is 151 out of 400, and actually no, not out of 433, out of 584, because that's the total. So the first thing you want to do is you want to add the two times, so 151 plus 433 is 584. So your proportion of yellow peas in this one is 151 divided by 584, which is 0.25856. And obviously you want to keep as many decimal places as possible as you go forward. I try to leave everything in my calculator, but you'll notice that the answer wants 3 decimal places. That means you need to keep at least 4. Because you don't want to round till the end. So if you do need to round, and with this formula you might find you want to round a little bit, especially as you go back and do the other half of the proportion, keep at least 4 decimal places. I usually keep 5, like insurance. Okay, so you're going to need that. We know that. So we know that that's 0.258 approximately. I'm going to keep more than that, obviously, because that's our 151 divided by 584. And obviously the most exact thing to use here is the fraction. And then we need to know the error. So we're going to add and subtract this from both sides. We need the z-score. We know p and we know q. That's just 1 minus it, or it's 433 over 584. It's the amount of green peas. And then our total n is the total number, so 584. So what we do need to look up for is the z-score. So I'm going to pull up, this is the z table. And we have 2 tails, and we have 90%, so that means that there is 5% in each, so I'm going to look for 0.05, and you can see it's right here. This is, again, one of the really common ones. It's marked. And so you can either follow it down here, and you can see it's 1.645. You can also follow it back there. There's the 1.6. And there's you can see it's right between the 0.04 and the 0.05. But again, this is so common that they always use it. In most parts, you only ever use 2. This and this one are so common, and they're so in the middle that everyone does always use the 2. The 3 decimal places. It's just kind of, that's what they do there, and that's the reason it's on the chart. Okay, so we're going to start plugging into our formula. And so what I'm going to do here is I'm going to move this over so we can see how we do this. So I'm going to start by doing this. So I just looked this up. This is 1.645. This is 151 over 584. And then this, and this because I'm not taking time, it looks really silly, but that's okay, is our 433 over 584. And obviously if you just subtracted this, it would also get this, and this bottom is this total, so this is 584. Then you simply get out your calculator. Remember, order of operations start in the inside. So I'm going to do 151 divided by 584 times 433 divided by 584. And that is not what I just got. Oh, because okay. Let's try this again. When I'm talking and putting something in my calculator, I often put the wrong thing in. See, 433 minus 584. There we go. I've got about 0.1917. Then I'm going to divide that. And as I said, I don't ever take this out of my calculator. I leave everything in because I want the most exact answer possible. So I'm at like 0.000328. I've got a very small number. Then you're going to take the square root of it. And again, I have not at this point retyped anything into my calculator. You need to learn to use your calculator to do that, especially with these rounding problems. Then I'm going to take this answer and times by 1.645. So my error is 0.029804. Then what I'm going to do is, so that's the first part of this. And then I need to find the confidence interval. So I know the E and I know my P. My P, of course, my P hat was 151 over 584. So I'm going to do, and I'm going to do 151 over 584. and I'm going to minus from my answer, and I get as my first value 0.229, because I'm rounding as I go. I've got 0.228757, but at this point I do want to round to my 3 decimal places. And I'm going to do the same thing on the other side. So 151 over 584 plus, and now at this point I have lost my calculator, and rather than re-enter it, I will use my error, which I wrote down, and I'm going to go with 0.029804. You'll notice I used a bunch of variables. It said is you need at least 4, but the more you keep, the better. And my other side is 0.288. And they should be fairly close, and obviously the closer you can get it, the better. And the bigger sample you have, the better values you have, the smaller this is going to be, and the better. And obviously, the smaller your confidence interval is. If you only 98% versus 90%, certain things like that. Okay, so let's check the answer. And then this, given the percentage of yellow aspirins is not 25%, do the results contradict the expectations? Well, no, because if we look at our confidence intervals, 25% is in here. We're roughly between 23 and 29%. So no, it includes 25%. So this does not do it. We don't know what the true one is. This just says that 25% is in here. So it's totally likely that could be the true proportion. We don't know what it is because, we don't have the population information. But based on our sample, this is possible.